start the introduction today. Okay. Okay, so we're gonna learn. So what we completed? We completed two things, right? Where we started with the introduction part. So where we learned about what is DevOps, what are the life cycles, okay, what is the cloud, etc. things. Then we started with the Linux part. So now very first tool of the DevOps which you're going to learn is Git. Okay. So we're going to learn about Git. So fine. So we'll learn today a little bit of Git overview. Okay, Git overview. Then we'll learn about what is VCS. Okay, what is VCS? Then we're gonna learn about um, benefits of VCS. It's most important. Then we'll learn about your types of VCS. Okay, then we'll learn about Git architecture, which is very important for this because everything is dependent on this. Okay, then we'll start with the installation of Git. Then we'll proceed with the basic commands. Then we'll move to the advanced commands. Okay, then before going to advanced and basic, there are a few concepts: branching. Okay, branching strategy. Branches and branching strategy. Okay, then we'll learn about merge. Okay, merge and rebase concept. We'll learn about advanced commands. Then we'll learn about cherry pick. We'll learn about uh, stash techniques. Yeah, stash techniques. Then we'll learn about GitHub. Okay, so GitHub should come. GitHub account creation. Okay, GitHub administration. GitHub administration. GitHub administration. Then we'll learn about again inside administration. There are a few more concepts. We'll touch that concepts like branch protection, most important for administration work. Then we'll learn about the collaborators. How do you add or how do you write permissions? Then we'll learn about Git and GitHub integrations. How do you connect your local to your remote? Okay, and then we'll learn about here Git tag. Okay, Git tagging. Okay, how do you put your stable releases? Okay, and so mostly like most of the covers will command in this basic are listed down once we start. There are like 6 to 8 commands which we need to cover. Okay, fine. So let's start with overview. Very first, what is Git? Because commands are good. We'll learn the commands. Commands are easy to learn. There's not a big challenge, but understanding Git is very important. Okay, so Git. When I say Git, right? What is a full form? Very first is what is a full form? Okay, global. Okay, interaction. People say global interaction tool. or some will say global tracking system. Okay, global tracking system. So mostly actually the abbreviation, if you find this one, people will put the effort here saying it's a global. This is Madhuri, right?
Yeah, Sagar. Sorry, I was late.
Well, the name says confusion, right? So
It's Bindu Avinash.
yeah, fine. So very first tool, okay? What is full form of that? So global interaction tool, or people say global interaction system, right? So what is this global interaction system? If I write what is this global interaction system, or what is this Git? Okay. So if you see in internet, people will give a simple definition called Git is a version control system. People say Git is a version control system. Okay, version control system. So what is the version control system? Before that, before I fulfill something about Git, okay, I want to know what is this version control system. Before I complete my definition, what is this VCS? In short form, people will say VCS. So what is this VCS? What advantages it provides for my Git, right? Why people say Git is a version control system? Okay, let's move on to that and let's understand, because the complete idea of the Git is here. Okay, when I say version control system, okay, version. So the definition itself says, okay, control system. That means the system is getting controlled by with some versions. I'm saying that I am managing some versions in my control, okay, in the system where I can control all the versions. Okay, so what I'm saying is simple. I'll write a plain English. Okay, managing some versions. Okay, versions, or I say unique IDs. I will say simply unique IDs or versions. Okay, so what are these versions? What are this? This is nothing but a, it is called commit IDs. It is called some commit IDs. These are in the hexadecimal number. Okay, which will be in this form of like some digits, right? You'll have some numbers, okay, some digits. So some random hexadecimal number it will be, which will be generated. So where it is not that readable format, but we say it's a commit ID. It says a commit ID, which is very unique, which is generated automatically by system. We don't generate it. Whenever it's this version control system gives a commit, okay, it will give in this format. Just remember this format. Where we give this, how we give, I'll tell you. Okay. This is okay. This is some SHA key in some format of 125 to 55. Okay. This is some formatted key. Okay. So this is, but I'm just saying now managing some versions and it is creating ID. But how it creates an ID, where it creates an ID, now let's learn. Okay, now let's learn. So very important. Okay, what is VCS? I told it is managing some version. Simple. Now again a question comes, why I require this VCS? Simply understand version control system. That means it's creating some version. For now, I understand it's only creating a version for me, some unique version. But why VCS? Why version control system? Why Git is called version control system, and what is this VCS? Why this VCS? So very first, okay, this version, when I say version control system, that means it's providing a version. So main idea of this Git is what? Main idea of this Git is for storing, okay. Git is a version control system which is used for storing some code. So basically the Git tool came so that it can store some code, right? So very first is a tracking, okay. Storing is there. We are getting storing the code. So very first thing, there is first important is your tracking the tool. Okay, so it means tracking the changes. Okay, second thing is memory optimization. Why? So now I'll get a doubt, right? Why should I go only with Git? Why not my folder? If this folder also of the some file we create, it also says me, right? If I see here text document, it says text document. Okay, date is modified, size is this much, right? In some of the files, if I go, it gives me a name as well. Okay, it will give me a name as well, author as well, it will give me, right? So if I see here, so some locations it will give me some author name as well, like it is giving say author. If you see my screen, type is Microsoft Word, author is Ashok, okay, and size is 20.7 KB, date is modified. So now I'll get a doubt, right? if I'm saying something is getting tracked by version control system, my Windows is also tracking. My Linux also gets tracked, that who modified that file, where it modified. Okay, I'm also getting everything from this here. So I can also store a file here. Also, it is getting tracked, right? So I can see here, if I modify this file now, it will come as my name, that last modified, who modified, what is the time modified, will modify. Also the size also it will get changed if I delete or modify. Then why I should go for this tracking? Why I should go for this tracking? When I say my Windows, okay, in my Windows also tracking is happening. So why should I go to here, right? In my Windows or my Linux also, this, it will say, right, we can get who modified, okay, who modified, right? Okay, what is the username, author, what is the name of the user modified, okay, last modification, okay, last modification date it will give, right, last modified date it will give us date and time, okay, then it will tell me the size also, size of that file or directory, whatever it is, right, of that file or directory. Then why should I go here? What is the reason to go with this VCS when my Windows or Linux is also providing? So here there is a drawback. What? Only I am getting what? This file has modified last date, but which line he modified? Inside the file, which line he modified? Whether he deleted a line, whether he added one line, whether he deleted one word, whether he renamed a word, I don't have information. So I'm getting a track that last this guy modified the file. Because in a, let's suppose there is a folder, okay, in your work company, there's a common folder but 10 people are working in that folder. Every time a person changes something, only his name is getting, size is getting verified, time is getting modified. But what did he change? Did he delete something? Did he add something? Did he modify something? That information is not there. There is where now, okay, so what is happening? Drawback is what? There is no proper tracking. That means there is no proper tracking. Okay, there is no proper tracking because we don't have what? We don't have info. We don't have info. What? Okay, simply which line? Okay, which word? Okay, or which sentence? Okay, is modified. Modified can be all the three, right? Whether he added something, he deleted something, okay, or he appended something, or whatever he did, right? Appended, delete, modified, whatever it is, right? So we don't have this info. Now take this example in real time. Let's suppose you are running a company, okay, you're running a company where few developers are writing a code, or some DevOps engineer has written some automation scripts, okay. So let's take an example, like past 5 years the company started this project, okay, and suddenly what happens, from the beginning there was a employee who started writing this code and everything along with some developers, okay. So suddenly that main person who was there, who left after 5th year. Now what happened? Whoever the people came, in the 4th year, 3rd year, were still able to get some information. Now a very new person, when this person left the company, new person came into company, how he will identify? When you have a common folder, like you have a common folder, now you're only getting that last modified, that means who are modified, you only get to know what is the code, what line he added, what method he added, what he deleted, what all things he has done. We don't have info when we go with this folder. But when it comes to tracking, okay, when it comes to our version control system, it says I will manage, I will track which line, which word, which sentence you edited. That means today what you edited, yesterday what the changes were there, okay, all these changes will be tracked, all these changes will be tracked. So here this was a drawback, but changing the tracking, right? So what it will do here, okay, let's put this down, okay. So now we got something about tracking, okay, something about tracking, okay. When I say tracking, okay, so what I'm saying, so when I say tracking, that means we are tracking the system, okay, or we say we are tracking a file, folder, okay, code, script, whatever it is, we are just tracking it, okay, etc. things. So here we get, okay, we get to know below things, okay, we get to know below things, etc. We get to below things. So what all things we'll get from the tracking? Let's see. So very thing, who modified? Very first I'm getting, that is I'm getting with Linux. Who modified? Okay, so here what Git will see is very first Git will have your username and email ID who are tracked. Okay, second thing, okay, which line I'm modifying. Okay, which line I'm recording it, right? Yes, recording is in progress. Which line, okay, which word, okay, which sentence, okay, sentence, okay, is modified, is deleted, about it's deleted, added, updated, okay, or appended something, or appended is updated only, right? So fine, okay, etc. So whatever things he has done it, we are tracking. Second thing, what time and date, okay, what is the time and date, okay, person modified, or date employee modified the file, folder, or etc. things, right? File or folders he modified. So now what is the advantage of this? So even if suddenly a very critical employee leaves the company, still company has something called a tracking system where they can track everything, like what 5 years before that guys had done. Whenever the project started from that time till here, whatever the changes he has done, each and everything is getting tracked. Each and everything is tracked. Okay, each and everything is getting tracked. Okay, each and everything is getting tracked. So this is what very first thing is tracking. Very first thing is tracking that which user modified, what was his email ID, and what all things has done it. Also, it will help in what? Security. Let's suppose there are 10 developers working, and by mistakenly, a very fresher who joined a company, he deleted by mistakenly, and now he is trying to escape from there. He's trying to escape because what he's saying, he's very scared, right? He doesn't want to tell that what happened. Suddenly might have he deleted something, and he just kept it quite there. So what will happen in this situation? Other developers who are there will get uh, some kind of a double work. They need to verify what happened things. Extra work will create, and some other person should not get blamed, right? Because of someone else. So there is where this tracking is brought into system, where some employees who is leaving the company and he say, I'm leaving the company, I want to delete all my code, whatever I'm written. So that kind of a mindset is also there for people, right? We can't judge people, because people are like that, right? People are like that, where people will think that I should do this before I leave the company. So all these things, because this is the base, whatever the code you're writing, that is a base for any product. Because you're developing the web pages code, you're writing some Java code, you're writing some Oracle code, you're automating your all the DevOps tools, scripts and everything, right? All the information is kept here. So it is very important to keep it very securely. That is the reason tracking came into the system, which says I not only I not only track this username email, but as well I will track which line, because Linux doesn't provide it, Windows doesn't provide it, that what was changed in that. That is important. Okay, if someone only the name is coming on the file, that doesn't give information, because after 1 hour some other users goes and modify that file, his name come into picture. So but I want what was the file modified, what was the line modified, what was added there, because that gives information. Because something has to be reverted, something has to be modified in the feature, something is failing in the runtime, all that things has to be fixed, right? So that tracking is very important. Very first is tracking. Now second important thing, I am saying memory optimization. Okay, first thing I got it that it's a tracking. So second information, okay, okay, I'll put it this without VCS. Okay, this is without VCS, and that is with VCS what we're getting. Okay, with VCS what we're getting. So I'm saying memory optimization. Memory. So what memory optimization I'll give when I keep in Windows. Okay. Yes. So first was the tracking one. Second is what? Memory optimization, right? So let's take an example. I have file called project.record.txt. This is a simple file. Okay. Let's suppose this is a simple file where every day there's no version control system now. Right now we don't have version control system concept. So let's suppose we are working on a common directory. Okay, my team is working on the common directory. Okay, so where we started working on one file, there is one file which is a main file for a complete project. Let's assume this one. So I say I started today, I started working, and there were 10 developers who started modifying this file, and we got some 1 GB. we got some 1 GB of data. Okay, 1 GB of data in this file. Okay, we have written some code, some scripts, and etc. things. Okay, and we have written this script. So today's day is completed. We started from morning, we completed 1 day of data. Okay, so what I'll say, okay, tomorrow morning, okay, this was a day 1. Let's suppose this is a day 1 activity where we started the working on this file. Tomorrow, again, we want to continue on the day 2. We want to continue on the same file. I want to continue on the same file, which is your project.txt. Okay, let's assume this one. Today, I wrote the fun file, which is day 1. In the day 2, okay, day 2, if I write starting on the same file, again, I will have 1 GB of data, right? And, sorry. Save this one. Day 2, again, I'll start writing on the same data. Okay, I'll write some data. Let's suppose I'll say plus. Again, I'm writing some 500 MB of data. All the developers wrote. So this will become 1.5 GB of data. But what a developer says, whatever I'm adding this 500 MB of data, whatever I validate or execute this code, whether it will work or not, I have no clarity. Because I wrote yesterday and they're saying, right, this was, here I'm saying it was working file, it is stable file, okay, where all the code scripts, what are the code, okay, what are the scripts written are in working condition, okay, working condition. So they say it's a working condition, it is working properly, everything is working. So now they say today what am I adding this 500 MB, it will work or not, I have no clarity. So people say I can't add anything in this file, I want a backup of this file. They will say I want a backup. So day 2, what they'll do before working on day 2, what these folks will do, they'll say backup day 1 data, backup day 1 data, and these people what they'll do, they'll take a backup of this. Simply they'll put it here and they'll create a file called backup, okay, backup underscore project.txt, and they'll put some date here. Let's suppose 12 2022. Okay, so here what they have 180 of GB. Okay, let me give some spaces though, so that it will be clear for us. Okay, this is one. Okay, they have a backup. So now second day they started. Okay, it's 1.5 GB. Whether they will work, it will work or not, they don't know. If it works, it's fine. So again, these people, what it's saying, this is also a working file. This is also a working file. Okay, this is also a working file. I want to take a backup of this. This is also working condition. Let's suppose in this project.txt, they are working on some login page feature. They are working on the login page feature, which was working fine. Okay, which was working fine. Now they are working on what? In this second MB, they are working on the okay, they are working on the logout page feature. Okay, they don't know whether this integration will work or not. They don't have idea. So there is where they told we will work on the second, we'll continue on the same page, but we'll have a backup. Okay, till now it's clear, guys? Getting what is tracking, what I'm explaining? Is it clear? Plain text, very
Yes,
plain
sir.
text. Fine.
Yeah, yes.
So again, they started working on second day, which generated 1.5 GB, and they say everything is working fine. Logit feature also worked fine. So they will come back to the third day now. They will come back to the third day. Again, third day, what a developer will say, I will work on the same page. I will work on the, where is my cursor? Where it went? It's here, right? Okay. Again, I'll say I'll be working on the same page. Okay. Now I'll be working on the main page. Okay. Where main page of the products, where all the products are displaying, I'll be working on the main page. Okay. This is the page I'll be working. So again, what you will have 1.5 GB, because 1.5 GB will start. But here again, he makes a condition that I really don't know whether that product page will work or not. I am not really sure. I will write a code, but it will work or not, I really don't know. So what will say, take a backup of day 2, whatever your have a backup, and give some name. And let's suppose this is 13th date. Okay, so what you will have 1.5 GB, 1.5 GB. Again, he will work on day 3. Let's suppose he's adding some 5 GB today. He worked very hard for that page. They established some 5 GB of data, which is 6.5 GB now. Okay, so 6.5 GB. So just assume if something every day you're taking a backup, so how much GB you will waste it here in without your VCS. This is without VCS. You're working on your system. When you're working on your any of this is on Windows example. If this is on your Linux machine and your Linux machine on what are the Windows or Linux machine, let's suppose it has a configuration. Okay, Linux/Windows machine can be any machine which has a configuration. What it has a disk of 20 GB only. Limitation is 20 GB disk. Okay, again you need to add a disk, again the space cost. So just imagine if this is only 3 days, what if this person will work for complete 1 month? How much data will these people generate? We don't know, right? They can generate 20 GB, 30 GB, 100 GB, or they can generate 500 GB. So what they're doing, they are wasting their data, their space with these backups. One side it is safety. I agree, safety is there, but business will not work in this model because what business will say, you do some cost optimization. Okay, you say some cost optimization because you have to work on the cost optimization because they need to run the business, right? For running a business, they say you work in a cost optimization model where you make sure you don't waste a lot of the memory CPU because that costs a lot of amount for them, where they need to charge, where this AWS people will be charging a lot of amount for us for the CPU memory. Okay, and the systems will be running 24/7 in our environment. So just imagine this is only for 3 days. These people are 6.5. What will happen for 1 month? Assume in an average, if these people will generate 2 GB also in a month, 60 GB of data will come, which is difficult, right? And also system will become slow. You need to add some additional disk. Your processing speed will reduce. Okay. Also, you need to maintain all these backups, right? To avoid this, VCS came into picture with a concept of what? Concept of memory optimization. It says I am not only for tracking, I am now for your memory optimization as well. How this memory optimization will happen? Let's see this. Okay, let's see how this memory optimization happen. So now let's take an example of same file. Okay, day one, our developers will start working on here. Day one, our developers will start working on it, which is project.txt. Okay, I started working on here. So these people, what will they'll start working on the login feature page. Login feature, they started working. They generated, let's suppose, 1 GB of data. Okay, 1 GB of data. Second day 2 started. Okay, day 1 GB of data, they say they started working. Second day, let's come to second day. And these people say, again, second day I'm working on the logout page, logout feature. And today 1 GB plus data plus 500 same GB. Okay, 500 GB of data, which is equal to 1.5 GB data. Okay, so now same thing developer will say, before I start working on day 2, where I don't know whether this login and logout feature will work together in the same piece of code in the same file. Now they have a doubt. Now what our VCS will provide in terms of memory optimization? Let's see what it provides. Now comes the concept of actual VCS, version control system. First it provided tracking, second memory optimization. Here is where the commit concepts comes. So what it will do is, when I say my file is a working file, it's a working / stable file, and every feature is working in this login page. Okay, stable file. It says stable file. So in this situation, what our Git will show, it will create a unique commit ID. Okay, on this file. It will get a unique commit ID, and what it will do is, and it will start recording the changes. Okay, changes. In a sense, what do you mean by recording? So whatever the code you have written, this commit ID which is getting created, which is creating in the hexadecimal code, right? What are the hexadecimal code? Sorry, let's suppose HXVAB, right? What are this hexadecimal code it is creating? What it will do, this VCS will assign one commit ID for all the number of lines you have written. What are the number of lines you have written in this file? Each and every word, each and every line is now recorded by this. That means this commit ID will go and point to this. This commit will go and point of this. The moment you open this commit ID, you'll find your changes, whatever the changes you have done, whether it's a new change, whether it's an existing change, whether you deleted something, whether you modified something. So it makes sure your 1 GB of data is properly pointed with this commit ID. Now, when it is saying I'm pointing it properly, I don't need to maintain a backup. Very first thing is, it will say you don't need to make a backup, because even if something goes wrong in this file, when adding this 500 GB and something is not working in this file, still your data is pointing properly. Commit ID. You can revert these changes easily. You can revert these changes and you can get it back. There's no manual effort here. Because now it is what Git isn't tracking control system. Each and everything is getting tracked. Each and everything is getting recorded with that changes. That means every time you write something, you make a commit on that file, that changes will be recorded. If you want that changes, we will pull you back with these changes. You don't need to make a backup of that file for a working condition. So people will keep continuing this process. Tomorrow, what will happen? These people will write something here with 1.5 GB. Again, we'll create one new commit ID. This is again a new commit ID, which will be generated with some new commit version, some XML version. Again, on this file, a new commit is generated and it will record. Record the changes. Okay, record the changes. Now what happens? Record changes. So what will happen? So whenever I open this commit, I will get only today's day 2 changes. Again, it is not showing day 2. Though it is 1.5, it will show you as original file. There is only original file. There is no duplicate file. Original file is what? Your project.txt. Original file is what? Your project.txt only. There are no duplicate files. Like here, there is no backup file, nothing. Original file is same, duplicate file on. You have your original file. There is no duplicate file. Only thing, it will work on the layer by layer. That means a layer is nothing but a commit ID. Sorry. So this layer is nothing but your commit ID. 1 second, guys. So this layer is nothing but your commit ID. So every time this will change, this will record these changes. So you no need to make up a backup. Whenever you want that particular change, open this commit. This changes will be in front of you. Again, what will happen? Even if you work next 30 days, in this format, same format, if you work with those commits, right? Every time you make a change, you create a commit. Every time you make a change, you create a commit. So what this commit will do, it will keep pointing the changes. It will keep pointing the changes. In that situation, what will happen? You're not taking any duplication. There is only single file. There is no backup file here. That means if here it is generating 60 GB for a month, here it is only generating 30 GB. Why? Because of this commit ID. Because here we don't have anyone who is doing a commit, who is recording that changes. We are manually taking a backup and we are making this file safe here. But here you don't need to make the file safe. It says you just create a commit. I will record the changes. Whenever you want that changes, I'll make sure you read that changes with my commit ID. Or if you want to revert the changes, you revert it. I will give you all the mechanisms of Git where you can maintain your changes with single commit ID. A unique pointer will point to your record.file wherever your each and every line is written. Each and every line is modified. I will make sure it is committed here. The moment you open me, I will give you your changes. So what it is doing, every file, it has a layer. Every file, every commit has its own layer of changes. Every commit has its own layer of changes. Every commit has only the unique data. But you open the whole file, it will give you, when you open this file, you will see whole complete data. But this data is segregated with the help of this commit ID. That means this commit ID is something which is making sure I will point only for your data. If you want specific data, open my commit ID. If you want to see the complete details, open directly file name. Okay, clear guys? Understood something? Got or didn't get the benefit of VCS? But it's confusing.
Got it, Sagar. Got it.
It's confusing. Shekhar, is it confusing? Madhur, it's confusing.
Nothing
Yeah,
like confusion.
Sagar, okay, Sagar.
You okay, right? Understood, right?
Okay.
Very
So,
important
here,
question. Very important question in interview. What is VCS? Why do you want to use VCS? First question
so
in
with-
last interview.
With
You will not
VCS,
find
we
this
no need to take the
information. You will
backup,
not
right?
find this information in any YouTube or any data. Okay, people will tell you what is tracking system, everything, but hardly some people will explain you this. This information will not get you. So people will ask you, is there only the tracking which is doing, or it is providing? Main is the memory optimization, because tracking is fine. Tracking, some other tool might also give you, but memory optimization is very important, because that refers to company cost optimization. If you're spending some 100 GB here and you're reducing the 50 GB of this cost, that means almost 50 GB, almost 50% of the money you're saving for a company. Okay, this is where it goes on. Okay, very true. One is tracking the changes, second is memory optimization. Tracking the changes is done by the Git with the help of this username, email, and it will validate which line, everything. Memory optimization is using a technique of commit ID, and this commit ID will make sure that which file and what are the changes it is recording. So now when we see the practical, you can see that I'll open this commit ID in front of you, and I'll show you that how when each commit ID is recording the changes specific to that commit what you made. Every time you make a small change here, you do a commit and open this commit, you'll see that change here. Okay, this is very important where VCS came. Any tool which is using VCS, it will have this feature of tracking and memory optimization. Okay, memory optimization. So now we understood these things. What Git is a version control system. Git is a version control system which helps in tracking the system. Okay, it is also in tracking the system and tracking the complete, let's put it, tracking the complete system. Okay, complete system and complete changes. Complete changes. Okay, complete changes along with benefit of memory optimization. Okay,
Optimization.
so this makes fulfill, but still the definition is not yet fulfilled. This is just a version control system. If I say Git is version control system, it doesn't make sense, because there are a lot of version control systems in the market. But now, why only Git we are using? Now question raises again. Till now what we did, we got, because when we're learning a definition of Git, it says Git is a version control system. Now we got a question, what is version control system? Why version control system? But now I'm saying Git is a, when I say Git is a version control system, I understood that VCS provided two features of tracking and memory optimization. Now one more question raises in my mind. Why only Git? When I say why only Git, why only, I just wrote what is Git. Now why Git? That question is coming in my mind. So that also we have to learn, right? So why Git came into market? So there is something called, let's put it here only. So why Git? Why Git? Before learning Git, before learning why Git, we need to learn something about, okay, types of version control system. Okay, types of, before I make you understand why Git, there is something called types of VCS. Here it will answer why Git. Types of VCS. Okay. Types of VCS. So let's move on. Why? What are types of version control system? So version control system provides two things. One is centralized. Okay, centralized VCS. One second, guys. Okay, types of VCS. One is centralized VCS, which is nothing but a centralized version control system. Okay. Second comes as distributed version control system. Now we need to understand these two concepts and then identify where my Git will fall, whether it will fall in centralized, whether it will fall in distributed. Then my Git definition will complete, and then my why question, why Git only, that will fulfill my answer. So let's start learning on this. centralized and version control system. So where is centralized version control system? Okay. And second one, we're going to learn about distributed. These two. So now let's move on to centralized version control system. So let's understand something diagrammatically. So now we understood that centralized version control system is something. Now only the version control system provides tracking and memory optimization. Now what is this centralized? So let's take an example. Let's suppose this is my server. In this server, there is a repository. Okay. What is the repository? I'll understand. Just assume a repository as one folder. Okay. Let's suppose there is one server. Let's assume there is one. Let's suppose this is one. Okay. This is one server. Okay. Okay. Let's assume this is one server. Inside this server, there is one repository. This repository is nothing but one folder. I'll just assume it's a folder. I'll explain you what is the meaning of repository, why it is called repository. But before, let's assume there is one Windows machine or Linux machine, any machine. In that machine on the server, there is one folder. I have one folder. Now, this is the workstation. This workstation is nothing but a developer's PC or a DevOps engineer's PC or any folder, laptop or desktop, anything from where he's working, his workstation. He's working from his workstation or PC. So now let's suppose there is one developer who want to update one file, which is of, which we say, one second, let me edit my mouse, right? Okay, let's suppose I have a developer who is editing one file. Okay, can I add your text? Okay, no problem. Let's take the text. Okay, because in draw.io it will come properly. Okay, there's a developer who is editing a file.txt. One file is editing. Okay, he's editing one file.txt. Okay, file.txt. So this file, when this guy is editing from this repository, so what will happen here? Okay, so what is going to happen here? So when I say centralized version control system, what will happen? This is a server which is a centralized version control system. That means there is only one server. In one server, there is a unique folder. There can be a number of folders. I'm considering there is only one unique folder. One server, one unique folder. That is why I'm saying it's centralized. It's in central location. It's a centralized. Now, by developer, what he's doing, he's going and he's editing a file. Which is your file.txt, which is a file.txt inside this repository. So now, what is going to happen? This person, when I say it's a centralized version control, he's editing the main file. He's editing directly in that server. He's connecting to this machine from his workstation, and he's connecting to this machine in workstation, editing a file. So now, when I say centralized version control system, there's a unique folder, there's a unique file. So whenever he updates something, this developer say, now I want to update in the same file. I want to go and update in the file.txt. Again, this developer will say, even I want to access the same repository and this same file. So what will happen? A version control system, the centralized version control system, what it says, okay, what it says, whenever a user is working here, no second user can update a file. No second user can update the same file. I say you can't update. Why? Since says it's a single original file and someone edits the file, there'll be a lock on that file. If someone is editing a file, there'll be a lock on that file. So centralized version control system says until this person is editing, until he saves the file, until he commits the changes back, he's changing a file, until that, no other developer is allowed to edit the file. There's a drawback in central version control system. So it says you need to connect to a machine. This is central machine. You need to edit that file, modify that file, save your changes, come out of that file. Unless until you can't change it. Unless until you can't change it. Now, let's take an example. What if this person is a fresher? Or this person by mistakenly, what he did, he's a fresher or he's an experienced person, he by mistakenly deleted a file. Inside a file, he deleted a file, or inside that file, he deleted some contents by mistakenly. Okay. And what he did, knowingly or unknowingly, he did a commit there. So what will happen? Next time this person goes and open this file, he changed that file contents are missing. File contents are missing. And whatever he added the changes, that also is missing. So this is a worry, right? Someone is changing mind. This is a unique file. If you lose the data, you can't revert it back. You can't revert that back changes. Again, what you need to do based on that commit, you need to update that changes, modify the changes, make sure everything's stable. Again, these people will also suffer. What if? One more example. One example is deletion. Second example. What if this person, let's suppose today is Friday. This person, what he did, he modified the file. He opened a file, he modified some changes, but he didn't save the file. And he left early on Friday because he had some personal work. What will happen if this person is working in the very late night? This person is also working in the very late night or in the weekends. He says there's a lock. And what a centralized version control will say, until you save the file or you unsave the file or come out of that file, we will not release this file to some other developer. They cannot make change. It will throw them an error saying that this file is occupied with this person. Please wait until he releases this file. He commit his changes or he undoes his changes and he leaves me that. He releases this file. So there's a two drawbacks. One is what deletion problem is there, security. Second is what if someone is locking that file, no other person can work. Okay. So what is happening? There is no parallel work. These people cannot work parallelly on this file, right? It is a very big problem. People cannot work parallelly on the same file. That is one big problem. Second is what? Data security. If no one doesn't save this work properly in this file, they delete something. Again, this is the problem with these people. That means version control system will not revert your file. Okay. Maybe there may be some backups, but some backup server might be there somewhere location, but it will take some 2 to 3 days to revert. Till that 2 to 3 days, will you stop your deliverables? Will you stop releasing a product to a customer? If there is some hotfix, something urgent in the middle of the night, so production system is going down, people has to modify some code, build the code and deploy it. In that situation, will they wait for 3 to 2 days? No, right? So all these problems were there with this centralized version control system, okay? And you need to be online every time. You need to connect to internet and every time you need to connect it here. So this was a problem drawback. So now this is about your centralized version control system, okay? Which has a central server, which has a single folder. People will work on that connecting to the server online, okay? And they will work on this. Okay? This is central. Now let's move to distributed. What is distributed? What is this distributed? Okay. The word says distributed version control system. What do you mean distributed? Do you mean that there are a number of servers of this distributed? Yes. Shikhar, any doubt?
No. Parallel way you can get it.
Okay. So distributed, when I say distributed, so it doesn't mean that this has some duplicate server and somewhere might it have some backup server, even like as your central server. Okay. Let's assume again, this is one single server. This is one single server. There is one repository, nothing but a folder. I'll give you the meaning of repository. So what this distributed says, here is a workstation, user is there. Here are the users there. So here we have 3 users. So this user, what it says, what a distributed says, you don't connect to this server directly. That means you can connect to this server, but it says you don't directly go and work on the same file. Let's suppose this is a file.txt which I want to edit. Take an example. I want to edit the file.txt from this repository. And this distributed says you don't edit my original file directly. Instead, it will say, why don't you download the complete folder as it is? Here it is saying what? You need to be online and you have to work here. But here it is saying, first you download the folder. That means you'd download the repository in your local workstation. Okay, in your local workstation, you download it. Okay, then you start working on that. So in this situation, what will happen? In this situation, what will happen? When it says you download, when it says you download, you say saying first time you download it here, you work on this repository, okay, make all your changes in your local. It says you download the folder in the local, you work it. When everything is good back, update me back the changes. So in this situation, what happened? These three folks can work parallelly. They can download the duplicate copies here, and still the original is saved. There is no data security problem. That means still my original is saved. Even this is getting deleted by a user in the local. When he's downloading a duplicate copy, even it is deleting in the use in the local, there is no harm to my central. Still these people can still access the files. They can make a change. They can get the changes. They can commit the changes. Everything they can do it. So this is the benefit of distributed. So coming to centralized. Centralized, what it says, you connect me online, edit my original file and make your changes. If something goes wrong, then there is a problem. Other people will not support. But distributed, what it says, you download my changes. You download your complete folder in your local. Work on that folder. Okay, work on that folder properly. If you feel that this changes whatever you're done in that file.txt looks good for you, only then you update in this repository, which is your main folder of your server, main folder of your company, where actual changes will be building the product, okay, from one developer. Same way, this also tells the same user. So in this way, what are two advantages? People can work parallelly. People will download it local, so that even something goes wrong in the local, still they can re-download it and work on it. So there is no harm in that. Okay. Okay. So these are the two advantages over your centralized version control system. And second thing, every time you don't need to go and connect online. You don't need a bandwidth. That means you don't need an internet every time, right? First time you require internet. Even if you don't have internet, you can still work offline, But here, what is the problem? You have to make sure you are online, because this is what centralized. This is somewhere located in a different location. You are working and you're connecting from online. You're getting the data from there. Okay. Because you have to be online to make the changes here. But here, once you go online, download it to your local. You don't need to worry about second time going online. So three benefits. One is the bandwidth. One is the data security, that nothing will be deleted in the main server. Third is parallelly working. Okay. Guys, clear? Yeah, Shekhar.
Yes, sir.
Yes. You can ask a question.
Yeah, Sagar.
Hmm.
See, after downloading the file, suppose you have mentioned there 3 workstations are there, and the work is happening individually, and later they can push back to the main folder, right?
Okay.
So while when someone pushing to main folder, so is the complete folder modified? Only
No,
update
only the
updation
file
will be
change.
done.
And only the modified file will go through. When you download for the first time, you're downloading complete change, complete as it is
Okay.
duplicate copy. Second time you edit a
Okay.
file, right? Only that file will get modified. You're not pushing a complete folder. Only that file will be pushed.
Okay, only modification will be, right?
Only modified file will be pushed.
So if in this case, Sagar, see, only modified files are getting pushed. Okay. So 3 different users, they're modified different in the same file. So only modified file is getting pushed into the repository. So, I mean, where would be the entire file then? I mean, the
entire file will be here only. Entire file will be
will
here.
will it take directly, or else do we need to do anything manually?
It will take directly. The moment you make a file change, let's suppose this file, this person is adding line 1. This person is what it is saying. He's adding some line 2. Okay, and this person is adding line 3. So every time you make a push, let's suppose these people are trying to push parallelly. So Git has a mechanism which will read it, whether it will say, is there any duplicate data with this person and this people is pushing the duplicate data? Then it will show some conflict error. It will throw error and it will say, who was the first person pushed? If this is the person who is pushing first, it will accept his changes. If this person is putting some duplicate data over here, it will throw error for this person and say, there's a conflict person, please resolve this and then make your changes. If the same person is making a mistake, he will stop it here only. So it has its own features, it has its own mechanism, which will stop you there itself when you make a duplicate data or a mistake, right? It will not allow you to push because that is very secure.
Oh.
Okay, got
Okay.
it?
So you mean to say the
Yes.
server itself will take the modifications and
Yes, yes.
give the
It will
entire file.
read it. It will compare. It will compare this file.txt, whichever it is there, right? Whatever this
Yeah.
person is pushing, first it will compare its original file and this file. If there is only change, new change, it will accept a new change. Okay. If this person is trying to push the same changes what this person is pushing, it will say it's a duplicate data. Please go and check with this person manually and speak to him and have a mutual understanding whether which changes should go, and then these two developers will speak to each other and then they will make the proper
Okay.
changes. Okay, there's a
Got it.
proper collaboration. There is where DevOps came into picture, right? DevOps is
Yeah.
where we are working as a one team, as a process for collaborating with different teams. Okay.
Sagar,
Yeah.
one more question.
Yeah.
Can some developers together push the data?
Yeah, they can push to data.
I mean, simultaneously
Simultaneously,
at
that
the
is what.
same time.
Yeah, it will accept. P. Simultaneous
Okay.
in a sense, fraction of second somewhere will be different. Even if the same data is pushed, both are different commit IDs, right? As per my understanding, which I
Yes.
gave you, both are different. So
Yes.
it has a mechanism which will accept both the commit IDs on this file. It will accept both commit because both are
Okay.
different changes, right? And further, Git internally will merge that changes into a single file. It has its own. That means it will
Okay.
combine the changes into a single file. It will keep internally. It will do all the background work. We don't have to worry about that because in a
Okay.
company
So
there can be 10
afterwards,
developers who are making a changes.
okay,
Okay.
okay. So afterwards, this downloaded file can be deleted, right?
Which one? Yeah, you can
Or
delete it.
whatever
You
the
can keep it. Whatever you want to do. If you want to keep in your local, you can keep it, or you want to delete it. It's up to your developer how you want to make. But mostly we don't delete it. Why? Because I'll tell you. Let's suppose this is of this complete folder or this repository is of 10 GB. So what will happen? How much time it will take you for download? A lot of time is required for download, right?
Yes.
10 GB is not a small file. It's very big.
Mm.
So
Yes.
first time you modified this file, you push the changes. Okay, you push the changes from this developer. This person is also pushing a changes, some different changes. This person is also pushing a different changes. So what will happen? Now this person who is there, he requires the new changes with this person fair. So do he needs to download the complete repository 10 GB? Already data is
No.
here. Only a file change, right?
Yes.
So he will keep this repository as it is. There are some commands called git pull commands, which will only pull the latest changes, whatever the changes people have done. Only it will compare these two folders, and it will say whatever in the comparison, whatever the difference I find, only the difference I will download it here, so that performance will be fast. Download performance will be fast, and it will be add a good mechanism where you're not downloading the same data and wasting your bandwidth, wasting your memory, or wasting your time. Okay, clear?
But of course, that is also good. But at many places, the 10 GB file is storing. Is that okay?
It is fine, right? It's in your local, right? You'll be giving some local space. If you don't want that, you don't do it. That is all local. So there is also mechanism
course.
which Git will provide you. I'll tell you about that. Is a
Okay.
fork mechanism where you have a GitHub server, right? Where you have a fork mechanism.
No, 1 second, Sagar. Actually, even we keep in a local machine,
Okay.
but sometimes, if it is completely on cloud, so that cost, no?
It will cost, right? It will cost definitely. You need to bear some cost, right? There's no other option. If you want to work on a project, there's a cost. If you say, right, every time you want to do that thing, then you need to download every time. There's no other
No,
option.
is there any alternate that
No,
to
there is no
minimize
other
this
option.
action?
There's no other alternative.
Okay.
Then
One
if
more
you
question,
want
Sagar,
alternative
sorry.
way, then your internet should be some 500 GB or 200 Mbps of speed, where it will download in minutes or seconds, right? Where you can do that.
Mhm.
But what will
Okay.
happen is that developer in real time, developer will, whatever he clones for the first time, he never deletes it, because this is what a remote location. In remote, somewhere in the remote it is there, but this is what is local, right? If a developer, he clones this one, what he will do, he will do some research and developer, he will play around this code. Why? Because he
Yes,
build a
yes.
feature, right? He will make
Yes.
sure this everything is going fine, and it is not here, right? Throughout the project, he will keep this. Why? He need to work on login feature. He need to log out feature. He need to make login and login integrate together. Then he need to work and build that everything, right? So he will never do it.
Yes.
This is for the first time he does it. Only he will be making sure that if someone he were to share it to some other developer, he will make sure only the changes are posted here. That is where the Git got famous, where lot of security is provided, where your actual code is not deleted. Because this is the main code, right? If this is deleted, that means your project data is deleted. Okay. And it is providing a parallel development. People are working parallelly, where they're developing a code parallelly and they're working on it. Okay. Fine. And there's no performance issue. There's no bandwidth required. Less bandwidth, less slowness. Because every time you go and connect to over the remote server from here, what will happen? There can be say latency issue where internet will be very slow. Sometimes the file will respond very slow. Even if you make a commit, it will take a longer time to do a commit. So all that issues will come when you do online, right? We can't predict the internet. Sometimes it can be slow,
Yes.
it can be fast. Sometimes the server is not reachable for us for a longer time due to some latency issue. So all these things, sometimes if the server is down, this person has to wait to make the changes, right? So there are some drawbacks. Okay. Yes, Madhuri, what is your question? Will be there any delay in
Sagar,
getting updates to repository, or it will be delay? No delay, because it's a one time, right?
Like
One time you're cloning it.
okay. If the fourth person after these three persons are used it and stopped using, if any other person get logged in, he will get all the updated file, right? Immediately.
Yes. Your internet depends upon your internet speed, right? How good your internet speed is there, that fast it will download. Okay. Even if it's some 100
But
people
the thing
will
is
clone
that-
this one, there is no issues. Even 100 people can download it. Any other question?
Yeah, Sagar. So
Yeah.
when you say, I mean, you suggested not to delete the file, right? Now, usually no one deletes the file, right? So let's say we have the previous file with us. So
Okay.
when we want to do the changes on the same file, as you said, like we can just use this pull command and we can download another file which has a new changes in it.
Okay.
Okay. So now we have two different files here, which
No
is
single file, no duplicate. That is why no duplication.
but we
It will
don't
be
have.
the old one which you have downloaded.
So what happens? This file.txt, the data is unique between those two. The data is same, right? Whatever the data you downloaded, it's a duplicate copy. So
Okay.
let's suppose this file is here. Okay. You have an updated file. Now this person pushed some changes. You want the
Okay.
new change in that file. Only this file name as it is inside this file, changes will update, but it will not create a, like in Windows, when you download, it says file.txt of 1, file.txt of 2. That concept is not there. It will go and update.
So when we use this pull command, we'll get the updated
Update changes
file.
automatically, it will verify, because why? This file is associated with some commit, right? Whenever you create a file, this isn't tracking Git, it's in Git control, it's not a local file. Git is tracking this file. It's not only you tracking a user, it is tracking a file. It is tracking the changes inside that file. Each and every line is getting tracked and recorded. So that's why it will compare both the folders and it will make sure what are the file exist here. And if the same file has some changes here, what it will do, it will go and update that file. If in case it doesn't find that file in the local, then it will download the latest file. New file, it will download and keep it here. If it has some same name file, it will compare the previous tracking, whatever Git. Whenever you bring this file inside a Git tracking, it will do a tracking. Git is very smart enough to track your files.
Okay.
Okay, fine.
So it's better we'll have to put all the files. We'll have to save all the files until we complete the project.
Yes. Okay. So you can play around with this, because that is where distributed came in system, right? Which provided a lot of flexibility to developers to work on it. Otherwise, what will happen in real time? What is to happen? Whatever developer is to work in the local, it was working fine. The moment who make a change in this repository, from this repository, when he's building a project, it was failing. So it was a lot of challenge there in the previous slide. Every time he had to connect to internet, download the file, upload the file, make the changes. Something goes wrong, he need to get back to the team who is very expert in the centralized version control system. They will fix everything. A lot of issues were there. Now this resolved that issue where it is giving flexibility. You directly download to local. You play around with this. You mess up everything. Doesn't matter. You mess up something. If something is deleted, delete this one. Download once again. That flexibility is provided to developer where he can play around with it. If tomorrow some feature doesn't work, Still there is no harm, right? Original code is same. You can still delete this feature and work again with the fresh features. So that flexibility which Git distributed version control system provided. Okay, clear about both these two differences? Okay.
Yes.
And also,
Sagar, one more thing. Actually, this is a job of a developer, right?
no, it's now it's not a
What,
job.
whatever you
Previously
are
it was job
shown.
of developer. It is not a job of developer. We are what I told you. We are the
That's what I just want to get the clarification. Here, what is the role of admin actually?
I will tell you. See, these many things are there. These many things are there. Okay, where we are doing a Git installation is our part. Okay,
Yes.
administration is our part. Protecting the developers is our part. Integration is our part.
Yes.
Okay, branching
Yes.
strategies is our part. So what developer will do? Developer is only storing his code. Developer is only storing his code. We will only teach him 3 commands. Okay, what commands? How to add a file, how to modify a file, how to commit that changes, and how to push it. One is git add, git commit, git push. These 3 commands only developer will use. But behind all the techniques are used by us, because we are the complete control is here. We will give him the access to developer. We will revoke his access. We'll give him admin access if we require admin access. We'll guide him wherever requires some different technique. We will take it. That is where control is in a hand. He is just a user. We are the admin. Okay.
Is it suggestible to give admin access?
It depends. It depends if you want to give. Okay, per team. If the team says tomorrow, because it depends upon the standard company. Depends. Some company says, right, why we can reduce some job of a DevOps here so that he can put some effort in some latest DevOps tools, right? And if let's company is working from last 10 years, is working on some basic tools. They want to explore some new tools like Kubernetes, Ansible, or they want to move to some complete to cloud or some locations. They will say, what are the regular operations we are doing where a developer can perform the changes? Let's hand over some of the workload to him so that he can troubleshoot basic issues, and a developer or a DevOps can go and move into the new tools. So it depends, right? It depends upon the requirement. If you want to give admin, you can give it. If you say no, it's restricted, you restrict it. Okay. It all depends upon the company rules, right? We can't assume that we have to go with the rules only. Company can divide the rules as well, right? It depends upon that. Fine.
Yeah. Why I asked that question? Actually, developer will not know all these configuration.
He will not know. We need to teach him. In case you want to make him a little bit of admin, you need to teach him. Okay.
Okay.
Makes clear till now it is understood things. Don't worry about this. I will write that liners, four liners. I'll write it and give it. Okay, clear this one. Now, one last thing we'll learn and we'll stop it here, which is your architecture. Most important, complete plays in this architecture. If you know this architecture, you know the Git. Very simple architecture. There are something like 4 stages of this. If you know this, you know the Git. So we will reduce this one. Yes. Yes. Okay. So in the Git, there are 2 things. Okay. One is the local. Okay. One is the local. Okay. Always remember Git. Okay. Git is a command line tool. Git is a command line tool. And there is a GitHub. Okay. In the GitHub, this is called a remote repository. Okay. This remote repository where all the actual code is stored. Actual code, that means complete code is stored here. This also stores your code. That means internally behind this there is a server which will store your code. Stores your code. Okay. Stores your code. And also what this it falls under what? Software as a system. I told something which you are creating an account, you're logging, you're using it. We are not installing GitHub anywhere. We are only installing a Git. This is okay. This is a command line tool. This is a command line tool which will install. Okay. This is used only to work in local system. Something you want to work in local, do R&D system, everything. Okay. Here also you can code a store which is local. That means specific to user. Okay. This is what specific to user. Your user account is here. You will do something specific to specific to user. Okay, this is not a shared location. If you want to share your code, then you have to make sure you update all the code in the GitHub. Update all the code in the GitHub. Okay, so that is where we understood this one, right? This is your remote location, this is your local location. So in the local, you will be working with the Git tool. In the remote, you have a GitHub account. This server is where your GitHub is where. Inside the GitHub URL, you will reach your server of the GitHub and your folder is stored. Okay. Now let's come back to the actual point, which is your local. So understood now. Git, this is your local. So that means this area, whatever this area you're working till here, it's your local. It's your local. Okay. And from here, whatever you're working from here, okay, whatever you're working from here, this is what your remote. This is your GitHub. This is your Git. Understood these things. Okay. Let's differentiate this thing in two. One is your Git, which is your local is your Git, remote is your GitHub. Okay, fine. So now, when I say a normal file, when I say here a normal file like Windows, okay, what are the original file or any file you're adding into this? So how it gets into version control system? So very first thing is your working directory. Your working directory. In this working directory, what will happen? Here is where you add a normal file. You just create a file, simple file, one vi.txt file. That's a normal file. Now it is not getting tracked. The moment you create a file in your Linux, that is not getting tracked. It's a normal file. Now, if you want your file to get into a tracking system, which is your version control system tracking, that means you need to bring that file to a staging area. Now you have a file or a folder, anything which is just a normal file or a folder. No one is tracking it. Only a Linux is tracking. In the Linux system, if you're a root user, that your root user is getting tracked by Linux. Okay? Linux operating system is tracking that as a normal thing. But Linux has a drawback, which you told, which line, what line, which word you're modifying, that is not then Linux. Now I want to bring this normal file into control of a version control system. That is a Git version control system. So what will happen? I need to add this to using a command called git add. The moment I add a command called git add, the whatever I want to bring into Git control inside a Git version control system, which will start tracking my file, that is called a staging area. Working directory is what? Whenever you modify a file, whenever you add a file, which is a normal file, every time you add a file, every time you modify a file, it will come as working directory. That means it is non-tracking file. It is not a tracking file. If you want to say my file has to be tracked, you need to bring in the staging area. Now, this is for the tracking. Second, commit, we told commit, right? The moment you make a git commit, this will start recording or changing in the local repository. In the local repository, that is what you're doing. So very first time what you're doing, you're creating a normal file here. The moment you add it to this repository or local repository, what you will say, it is coming to Git tracking. The moment you commit the change again inside this, then it will be recording that changes. That is the two things which we learned here. One is what tracking, second is a memory optimization, in which we started recording that changes. Okay, that recording the changes will happen in this local. This is your local. Now it is in your Git. Now if you want to share it as a collaboration to a different folks who can see it, then you do a git push. Okay, you do a git push. Forget about this checkout and this merge. This is not right now, not required. There's a different concept over there which we'll learn. So just understand, this is what you're going to do. One is your local, which is called your Git. This is your GitHub. Whenever you add a file or you modify a file, okay, let's suppose you add a file, new file, that is non-tracking file. It will come into tracking only when you do a git add. It will come into staging area. And when something you commit it, that means something starts recording the changes, that is in the local repo. If you want to shift it to a remote, that means if you want to give it inside a main repository, then you do a git push. This is what the remote. Okay, this is what your remote where changes will done. Okay, if you want to pull from remote, do a git pull. Okay, git pull. So clear about what is the committing, how the recording is happening. Now let's suppose I am saying it's a new file. I am saying what? It's a new file. New file is added, it's non-tracking. What if my file is in a tracking location? There's a file which is already, let's suppose there's a file called F1. There's a file called F1. Okay, f1.txt. There's a one file which is f1.txt. This file is which is already in the local. I didn't push it to remote, but still I say I missed some changes to add, right? Again, what I'll do in Linux, how do you edit a file? Use a vi command, right? Vi file name which you take, which will edit your file, right? Vi file name.txt, vi is a editor. Again, what will happen? First time when you added this file, you made a commit. You made a commit, right? You made a commit here. So you made your commit here, right? So you made your commit. So you made your commit here. Second time, again, you're modifying the same file, which is v1. So what it will happen? Git will bring your changes inside the working area again. Why? Because first time I tracked the changes. According to our tracking system, what I told today on the same file I was working, developers were working. He says it's a stable. He did a commit. Again, if he modifies the same file, has to create one more commit, right? Same way, what I'll do, I'll be creating one more commit. Even if I modify the same file, I need to make sure I create a second commit, and then it will go to staging. It will come to this. This has to follow the same pattern. Again, if I edit the file, it will say what are the contents were there, that is tracking with a commit. If you adding a new content, it says again this file changes are untracked changes. Again, it will say added to the staging area, which will come into Git tracking. Again, it will say your local repo, which will say commit. That means because same file can be modified by different developers, right? Today, one developer he modified, he did a commit. Tomorrow, again, different developer will come, will modify the commit. So doesn't mean that tracking should happen, right? If you're modifying this file here multiple times, okay, that means every time it comes to working area, today one developer who modified here changes, he created one commit. Tomorrow, new developer will come who will edit that file. Again, it has to come here because it's not only a commit, it's also the user who modified that file. So two things are happening here. One is in the staging area, tracking is happening. In your local repo, your commit is recording the changes. That means two things. One, who modified the person, who modified the file, who added something, who deleted something, who appended something is getting tracked here. This is your tracking your changes. Second, your local repo, right, which is your recording that changes. It is pointing a pointer. It is pointing a pointer, nothing but your commit ID, right? Commit ID, what it will do? It will make sure what are this person added here. I should record that changes. Clear? Clear, guys? Any doubt? And finally, you can push it to your remote, which will get it visible to other developers. Clear, guys?
Yes, Sagar. Yeah, it's clear.
Very clear or still not clear? Yeah. Shekhar, Bindu, clear? Sorry, Madhavi.
Yeah, it's clear.
Yeah, Sagar, it's clear. Okay.
Fine. So this is the complete play. Every time you play with a file, every time you edit a file, first time when you add, very first time, it's a non-tracking file. You add it will come to tracking. When you commit it will commit the changes. If you're modifying the same file is in tracking already, but the changes in that file is not getting tracked. And although a new user come, his data should come here, right? So these things we need to identify. Here. So we will play with these commands tomorrow. I'll show you that changes. Okay. So we'll start with your basic Linux command. Okay. Don't worry about the notes. We have a very good notes where you'll get a lot of things to learn. Okay. Each and every definition is here. Detailed definition also here. Okay. What things you want to learn. Each and every detailed definition is here. Okay. And also write in the same running notes. I'll make sure. Now tell me, you guys should tell me a answer. Where does my Git will fall now? Whether my Git will fall under distributed or centralized version control system. You guys should answer me a question now. You fulfill the definition. When I said Git is a version control system, which will track complete system, complete changes along with benefit of optimization. Now you tell me where my Git will fall, whether it will fall in centralized or distributed. Now the question is open to you guys. Whether it's a distributed or it's a version control system. Or a centralized version control system. No idea. So Git is a distributed version control system. Why?
So,
yes.
Can you repeat? Can you repeat your question, Sagar?
So that means where does Git fall now? When I told Git is a version control system, and in the version control system there are two things, right? Centralized and distributed.
It's a distributed one.
Okay, because it is providing all the flexibility of cloning and everything, right? And every time you modify, the architecture tells us what it is doing. Architecture tells us what it is doing here. Clear?
Yes.
Yes, sir.
Fine. Okay. So let's stop it here. And don't worry about these notes. I'll update these notes and push it there. Tomorrow we'll start how to install a Git. Very first, using the same RPM or yum install commands, we'll start installing a Git, and then we will start with the basic commands. Okay. First, we need to play with these basic commands. Once our hands-on are very clean with these basic commands, we'll jump into the remote side, which is a GitHub account. How to create a GitHub account, how to work on this commands. Okay. Fine. So let's connect already. It's 9:46, right? We'll connect tomorrow. This is important.
Okay.
Okay, sir.
Main is this stuff. Commands are very easy, dead easy. Commands are very dead easy. Only thing is this, understanding this concept is important. What is VCS? Now you can fulfill your definition saying that Git is a distributed version control. Git is a distributed version control system. Okay, Git is a distributed version control system which helps in tracking the complete system and complete changes along with the benefit of memory optimization. Okay, clear? Fine. So now why answer is also cleared with the help of this distributed version control system, which provides the flexibility, which provides your no bandwidth. It is not taking any bandwidth, it is taking less bandwidth for you. Okay, performance issues will not come in feature. Even something mess ups in your local, still you can recover in that from your remote locations. Okay, fine. So any other doubt, guys, apart from this? Also remember 4 things in your architecture. There are 4 things. What are the 4 things? Working directory, non-tracked area, staging area, which is tracking area, local repo where all your commits are stored, recording changes will happen here. Finally, a remote repo is where your actual changes will be stored. Okay, this is your remote repository where actual companies will start storing the changes. Here also what will happen? Not only your files, along with your files, commit should go. Why? Because commit is associated with your file changes. Every time you make a change in the file, this commit is the one which is recording the changes, right? So commit is important. This commit will have your user details, okay, your commit ID, and all the changes it will have. That means whenever you're pushing something, whenever you're pushing the changes, that only doesn't mean only a file is going. Along with that, commits also going inside this, because commits also should store, because the file changes and commit will go parallelly. Okay, because commit is the one which is recognizing in which file, which line, what file or what is modified there. So commit is the one which will record each and every changes. Clear? So we'll see this, how this goes, how this get clones, how we push it, how do you remove, how do you add, iterate, everything will come in tomorrow's class. Okay. Chalo, then if
Sure,
no
sir.
doubt-
Sagar,
yes.
could you please share me your number, please?
You want my number? Sure, I'll share your number.